I'm going to do a demonstration of Hamann Automat E calculator from the mid-50s. It has semi-automatic multiplication and automatic division. So let's see how the machine is structured. We have the input register where we put input that appears over here by using these levers. Can control it. Then we have the main output register, and this register is going to count the number of repetitions, also depends on the position. So in the case of this machine, we control the position of the output register as well as the repetitions register. We can do it like this or like this, or we can, so now the spring is fully extended, so we now can use this to control the movement, or this with a little more of effort to move on the opposite direction. So there are many alternatives on how to move this. So we have some values over here on the input register. We are going to clear them with this lever over here. Now everything is clear. We can also set up values here on the output. And how to clear it? Well, we can clear with this lever over here. So clearing of the output is electromechanical. So now we are going to position this so that we have the units digit aligned with the units in the input. We are going to add a number, so say 34, we're going to add it over here. These two levers control what is going to happen in the, well, this one will be used for division. This controls what happens on the repetitions register once we add something. So it is on the plus position. Here it will be on the minus position. So let's add, see what happens. So I'm going to press once. So now we have 34 over here, and the repetition here indicates 1. I can add again. And you might notice that we are not clearing automatically the input register. So as we add, we can also subtract and see also what happens here. So there's a slight movement here, and it subtracts. And so we can add it and subtracting the same number. So if we wanted to input different numbers and then clear the registers, we can put the automatic zeroing over there. And now once we do an operation, it clears the input register, so we need to put another number. Okay? That will also happen for subtractions. This control is going to control the direction of what happens when we are adding and subtracting over here. So let's try with some, well, we don't even need a number, so we are adding, say, 33 over here. It added, it cleared. So the repetitions register is indicating 5. If I do something else again, I'm just adding 0. It goes to 6 as I add, 7, 8, and then as I subtract, it goes in the other direction. So if I pull this lever up, it's going to reverse the direction. So now that I'm adding, it decrements, and now when I subtract, it increments over here. So this is the function of this lever. So let's get back to this. And we are going to show multiplication. So let's clear everything. And we are going to put a very interesting number. 9, 7, 6, 5, 4, 3, 2, 1, and we keep a 0. So the interesting thing is that if we multiply this number by 45, we'll get an even result, everything with 5s. So we need to multiply by 5 first. So we are going to produce a 5 over here. Actually, this is the result, so the 5 will get over here. So we have 5. And now we need to multiply by 40. So we do it by moving one position. There's a position indicator here, also here, and we are going to do this again, and we have our result, which is quite even. Now there is some other function I want to tell you about this thing here, is that when I clear, suppose that I wanted to clear this one, but not clear this one, so I can press this button here while I do the clearing, and it will protect this register from the clearing. So let's try something else. Now we have a number here, one here. Now I'm going to protect this one from clearing. Okay, and if I don't press, I clear everything. So now let's clear the output, actually the input, and let's proceed and see how we can do a division. So for the division, we need to put some number over here. So we are going to put 3, 5, 5. So sometimes this is a little bit hard on the fingers to do this. So there's an alternative. I could use a machine and do an addition and get the number here. So let's clear. Let's put it over here. It's much easier to set the number on this side, on the input register. Now I just add it. I have 355 here. Now I can protect this one while I clear. I have zeros here. So I'm in the position that I want. So this is a number I'm going to divide, and I'm going to divide it by 1, 1, 3, and this is a known way, this fraction, to get an approximation to the number pi. So I have 355, 113. The machine is going to automatically see how much times it can subtract this number from that number. Once it subtracts one more, it's going to see that it's too much, going to count the number of subtractions it did, and it's going to backtrack and get the remainder of the subtraction over here, shift one position, and this is going, and then again subtract a 10 times smaller number. So this is going everything to happen automatically when I press these two levers at the same time upwards. So let's prepare, go for it. Okay, and we have the result, pi approximation. So 3, 14, 15, 9, 2, 9. This is the remainder, this is the input register. Now let's clear everything and prepare to see the final feature. Let's put this lever back. And this final feature shows that we can transfer some result from here back into the input register. So it doesn't work perfectly on this machine, so let's hope that I'm not going to crash it with this last operation. So I'm going to clear everything. I'm going to put something, well, let's put a small number over here, 44. I'm going to produce a 68, and now I might want to have the 68 over there, so I could simply input it, but I want to transfer from the output to the input register. So this is an interesting operation. It's a combination of doing clearing and then doing the transfer with this button. So we need to clear, then keeping the finger over there, we do the transfer, and well, I was lucky. It went very well. So we have 68 here. So now I could add it again, and then I could put the 136 over there. Let's see if it goes well also. And it went well. So let's clear everything. And actually it was still yellow over here, so now we can clear and clear everything. And this concludes the demonstration of Hamann Automat Model E from around 1955. So thank you.